It is only in the last 100 or so years that humankind has understood that the nucleus of the chemical elements is not always fixed. It can change spontaneously from one element to another. The name for this process is radioactivity. You probably already know something about the nucleus. It's much tinier than the atom. It's made of particles called protons and neutrons. There are electrons orbiting around it. And though the atoms can share or swap electrons when they bond together, the nuclei themselves never change. Right? Well, no. Certain nuclei are not stable in that way. This means they may change suddenly, spontaneously. The radioactive nucleus flings out a small particle and transforms into another element, just like that. For example, a carbon nucleus can eject a fast-moving electron and turn into a nitrogen nucleus. There are two different particles that can be emitted from radioactive nuclei, though never together. The very fast electron is known as a beta particle. If you know a little bit about electrons, you may be thinking, what was the electron doing in the nucleus in the first place? The answer is that a neutron in the nucleus spontaneously changed into a proton, which stayed behind, and an electron flew out as a beta particle. This is not what chemistry has taught us to expect. The nucleus is supposed to be stable. Neutrons don't change into protons, except sometimes they do. The other particle that emits spontaneously from an unstable nucleus is alpha. An alpha particle is 8,000 times more massive than beta, and it's a bit slower. Alpha is made from 2 protons and 2 neutrons. If we trap a lot of alpha particles together, we get helium gas. Alpha is a helium nucleus. Like the beta particle, we would not have expected a heavier nucleus to throw out helium. But again, it happens, and the nucleus becomes a new element. So, is radioactivity useful or just dangerous? Wherever you are sitting, it is quite likely that there is a device nearby which contains a source of alpha particles, a smoke detector. The source is radioactive americium. You are totally safe from these alpha particles, which cannot travel more than a few centimetres in air. Beta particles penetrate much further through materials than alpha can. Radioactive atoms are used in medicine as tracers, to show where chemicals travel in the patient. Beta particles are emitted and have enough energy to emerge from the body and be detected. There is a third type of nuclear radiation, gamma, which is not a particle at all. It is an electromagnetic wave, like microwaves or light, but it is actually 1,000 times more energetic than visible light. Gamma rays may pass right through your body. Gamma is used to zap the bacteria in fruit to increase its shelf life, or in radiotherapy to kill cancer cells. Radioactive substances get hot, and this heat can be used to generate power. This heat has been put to use in space probes and, in the past, in pacemakers for hearts. The more abruptly nuclear radiation is slowed down, the more damage it does to the atoms it hits. This is called ionization. Alpha causes the most ionization as it crashes into other atoms, and gamma the least. For humans, the most serious effect of radiation is the damage that it can cause to our DNA. Although alpha cannot penetrate your skin, if you inhale or ingest a radioactive nucleus, the health consequences can be severe. Radioactivity is both useful and deadly, but it is all around us as a background to the natural world.